function and relation. First of all, chapter A is talk about a lot of definitions. So the first definition is the definition for the set. Okay, why do we learn this chapter? I'll let you know why do we learn this chapter. Because this chapter is helping us to define all the functions and how do we define the domain and the range. So when we talk about what the x could be, what the y value could be, let's talk about domain and range. And then we need the set, like the set to describe the domain and range. So that's the everything together you are like using is a helpful chapter to help you for later study. It's not going to be tested separately, but it will be tested all together with function and relations. Set notation. The first definition is set notation. So a set is a collection of objects. Okay, the word is a collection of objects. So how do you represent a collection of objects? We use the curly bracket. Okay, we use the curly bracket. Even though it's just collecting one thing, that will be a collection of objects as well. So I put 1 in the curly bracket. That's a collection of number 1. Okay, I'm collecting number 1. So this curly bracket means a set. If you don't have this curly bracket, for example, 1, 2, 3, ... this is not a set. It's just a listing of numbers. Okay, I'm not collecting numbers. So the collection of objects means we use curly bracket to put the thing we're interested in the curly bracket, and that's a set. Okay, that's a set. So everything when you see with a curly bracket, that is actually a set. Why I'm emphasizing that so many times? Because it's really important. Okay, we'll use that later. Elements. So the objects in this set are known as elements. So all the things in the curly bracket, what you put into the curly bracket, that's called the element. Okay, this curly bracket is necessary for a set. There will be some extreme case you don't really need the curly bracket and it's still a set, but that's like 1 or 2 exceptions. So curly bracket is necessary for the set. The third one is that we use comma in between the elements. Okay, we use comma in between the elements. Number 3 and number 4 is really important. So we have 2 symbols now. It's talking about the relationship between 2 things. Okay, 2 symbols talk about the relationship. We have belongs and not belongs to. Okay, we read this as belongs to and not belongs to. So it's like a 3. Okay, so how I read that is like this. And then not belongs to, well, sometimes can be quite ugly, but it looks like a 3 and with a line. Yeah, C with a line, so I'm normally writing that way. So this is talking about some element is in the set or not in the set. Okay, belongs to the set or not belongs to the set. So the set is like a club, and then something is like a member. Like, is that person a member of that club? Like, do I belong to that club or not? So X is an element in set A. We read X belongs to A. So X is a member of A or not. So, example, 2 belongs to a set. Okay, 2 belongs to that set because 2 is one of the elements in the set. We read as X is a member of set A, or X belongs to set A, or X is in set A. So, all good. X not belongs to A means A is not an element in the set A. So let's say the set is a collection of odd numbers like 1, 5, 1, 3, 5, blah, blah. 2 is not an element of that set. Okay, 2 is an even number, so 2 is not belongs to that. So use not belongs to. Okay, very important thing. Those 2 symbols are used to describe the relationship between the element and the set. So your left hand side needs to be an element. Element means no curly bracket. Set means with curly bracket. You can't use 2 things with curly bracket left and right use the symbol. You can't use those 2 symbols. So left hand side must be something without curly bracket, and right hand side must be a set, something with a curly bracket. So it must be an element and a set. We talk about the relationship between that and that. We use belongs to and not belongs to. Why I emphasize that? Because we have the next one is contained and not contained. Okay, this symbol used to talk about set and set, the relationship between set and set. We have set A, we have set B. We talk about whether A is contained in B or A contains B. So we talk about set and set, then we use those 2 symbols. So it's a C with a line and here. Okay, contained and not contained. So we can say 1 and 3 is contained in odd numbers because the odd number set, okay, first of all, there are two sets. Okay, there are two sets. And then 1 and 3, in the first set, the element 1, 3, also in the second set. So odd numbers 1, 3, 5, blah, blah, blah. So 1 and 3 is part of the next set. So we use the symbol contained. We use the symbol contained. In some extreme case, this is totally contained in that one. We still can use the symbol. So it's a fully contained. Okay, if B is not a subset of A, we write B is not contained in A, but they are both sets. They are both sets. So 1, 2, 4 is not contained in odd number because odd number is 1, 3, 5, 7, 9, like keep going. Even though 1 is in the next set, but 2 and 4 are not elements in the next set, so it's not contained. Even though it's only one element which is not in the second set, it's not a contained. It's not contained case. Okay, I can't say it's contained. It's not contained. Any questions? No. Okay, so emphasize again. The top two symbols used for connecting elements and set. The bottom two set, like contained and not contained, is used to talk about set and set. Okay, set and set. We are going to do a question in 1 minute, so you must remember this. Okay, then I said like there are some exceptionals to talk about like set. We don't use curly bracket. For example, this symbol. This symbol is a set. Okay, so this symbol is a set already. I don't need a curly bracket around that. So that is already talk about the set. But it's a very special set. So this equivalent to empty set. Okay, a set with nothing. This is called an empty set. This is equivalent to nothing. Well, it's very strange to look at a curly bracket with nothing in it. So we create a new symbol for it. It's called like empty set. Like it's a 0 with nothing, like slash, like empty. This is a set. Okay, this is a set. So next one is called intersection. Intersection is a set of elements common to set A and B. Is called intersection of A and B. When you talk about probability last year, I think you talk about intersections. For Venn diagram, there will be intersections. Some elements both in A and B will be the intersection. Therefore, you can say, again, so it must be a set intersects another set and give you a new set. So set intersects set equals to another set. So set intersects set equals to a set. So 1, 2, 5 intersects 1, 3, 5. So the intersection is 1, 5. The elements which is in common is 1 and 5. So it's just intersection of curly bracket 1, 5. Okay, so it's very important to understand set notation. This set notation. So A intersects B equals to a set. So now I'm explaining this set. So this set means a collection of X. Okay, curly bracket X means a collection of X. So a collection of X. Okay, and the column here means such that. I'm explaining. That means such that. After that is the explanation. So such that X belongs to A. It belongs to A. Also, X belongs to B. Okay, so I'm collecting a set of X. But what's the requirement for X? X is an element of A and also elements of B. Okay, that's what's the explanation for the intersection. It's nothing new. So the whole thing just means you find the common thing and put in the set bracket. But how we can write in the set notation is a collection of the elements X. What kind of X you want? Explaining. X is in the element of A and also element of B. So That's the explanation of what is intersection. Okay, what is intersection? Okay, next one. Disjoint. Disjoint. Well, it's just a definition. Disjoint means A intersects B is an empty set. A intersects B equals to empty set, so nothing in the set. This is called disjoint. Which means there's no common element in A and B. They are disjoint. The best way to represent disjoint is like that. There's no common elements in A and B. They are disjoint. Okay, they are disjoint. Yes. Union. Okay, union. Union is, well, like you know what's union probability. Like A union B is everything in A and B. Like anything in A and B. Okay, all in common. So anything in those two circles will be union. So union just listing everything out in both curly brackets. But like you're not repeating terms. For example, you have 1 in both sets, you just say 1 once. So the element will be 1, 2, 3, 4, 5. That's the union set. Okay, union is easy to understand, so we need everything. Have A and B, we need everything here. Okay, we need everything here. Set difference. Set difference. This one I think is a new thing to you. So what is set difference? Let's have a look at this explanation here. Okay, just look at this explanation. A set difference B, like A slash B, is a collection of X such that X is in A, but X is not in B. Okay, can you read the set notation that way? Like it's very straightforward. It's a collection of X such that X belongs to A. X is the element of A, but X is not the element of B. So X will be in A, but not going to in B. Okay, so you find elements that belongs to A. It's a member of A, but also it's not a member of B. So we can see that's a set difference A slash B, like in A but not in B. So we will we can choose from 1, 3, and 5, but you don't want 1 and 4, so you cross the 1 out. So it will be 3 and 5. 3 and 5 is the element in the first one, but not in the second one. So the set difference means in the front one, but not in the back one. So I can't have 1 and 4, but I can have 1, 3, 5. So overall, I can have 3 and 5 only. That's the set difference. Okay, that's 9 definitions. Well, some are revisions, some are new things. A very important one is the belongs to, not belongs to, contained and not contained. I want you to try the next page, like the question next page. For the first one, use those 4 symbols to put into the correct place, and then number 2, talk about all this set. Okay, what's the intersection, what's the union, what's the set difference. Give you 5 minutes to do this, and while you're doing this, I want to check your homework from the first chapter. Can you just put your chapter 1 notes on the table and also your exercise book together with that? I'll just go through to check that. Okay, tell me what you put for the first one. Which symbol you put? Well, belongs to, not belongs to, contained and not contained. Which one you put? Contained. Good. It needs to be contained, not belongs to. because it's connecting a set and a set. Okay, for the bottom one, which one you use? So, belongs to. Good. Okay, for A and B, what's A and B? Set. So, does not contained. Does not contained. Okay, 1, 3, 7 and B, what will you use? Does not contain. Good, because 1 is not an element of B. Okay, B and A. Does not contain again. Okay, 5 and A. Does not belongs to. Okay, it's an element and a set. Does not belongs to. Okay, A intersects B. So you will have 3 and 7, but it needs to be in this set. Okay, it needs to be in this set. You can't just list the element. It needs to be in the set. A union B is 1, 2, 3, 4, 5, 6, and 7. There are commas in between. Okay. What's A slash B? Yep, 1, 2 only. And what's B slash A? 4, 5, 6. That's good. Okay, so now we totally understand what is to be used: contain, not contain, belong, not belongs to, and then we know like the set, the notation for the set. So let's go for the next one. We have set of numbers. We have set of numbers. So there are some symbols to represent particular set. For example, I can say we use symbol A to represent this particular set and B to represent the other one. But there are some particular letters just used for a special set. So for example, the first one is the number n, natural number. So the n is just used to say the set of 1, 2, 3, 4, 5, dot, 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 like counting numbers, like it's counting numbers 1, 2, 3, 4, not including 0. Natural number does not including 0. So n use 1, 2, 3, 4, 5, and so on. Next one is integers. Integers, there's no smallest or largest number, so middle is 0. So 1, -1, 2, -2, 3, -3, all the integer numbers. Z, we use Z to represent integer. I don't know why I said, but like we use Z to represent integer, but Z plus to represent the positive integer. Therefore, n and Z plus are equivalent. Well, I can say same. N and Z plus, they are the same. Because Z plus is the positive integer. What's positive integer? 1, 2, 3, 4, 5. So same as the natural number. Okay, negative integers. Negative integers. -1, -2, -3, dot, dot, dot. We use Z minus, a minus on the right corner. Yes? Is 0 a positive integer? Do you think 0 is a positive number? That's the question. No, there's not. Z plus only use positive integer. So, is that a negative number? No, it's not. It's just not including both. So that's the next question. Do you think Z plus this set union the Z minus that set will give you the whole Z set? Is that a correct statement or not? No. Okay, you give the hint. So why is not correct? What's missing? 0's missing. So 0 is missing from left hand side. So I don't have 0. So Z plus not including 0. Z minus not including 0. So 0 is not positive number or negative number. So it's not including either of this set. So it's not equivalent. So we will say Z plus union Z minus and union another set, which is the set contains 0. That will give me the whole set of Z. So union another thing. Union 0. We're missing a 0. We need to union something, but what we need to union needs to be a set. Union a set, so 0 needs to be put in the set. Okay, 3 symbols. Intersection, union, and set difference. They all need to connect. Right, let's say we need to put set and set. Okay, we used to talk about set, union set, set intersects a set, or set difference another set. So it needs to be set on left hand side and right hand side. Okay, I want to finish talking about the number notations, like the special notations. We have another letter Q. Q is used to represent rational numbers. Okay, what are rational numbers? Rational numbers, the definition is number can be put into the fraction form. Okay, in the form of fraction. If something can be put into the fraction form, then it's called a rational number. So integers are rational number. Okay, 3 things are rational number. The first one is integer. Integers are rational numbers because 2 can be put into the fraction form 2/1. That's a rational number. Second one, terminating decimal numbers. Okay, terminating, so 0.1219, terminating, stop. Well, I can have 100 decimal places, but it's terminating in the end. That can be put in fraction. How? 1219 over 10,000. Yeah, that's a fraction. That's in the fraction form. If it's terminating, I can always put the integer over like a fraction, like how many zeros, like 10 to the power 6. Well, circulating or say recurring infinite decimals. So something like 0.212 1212121 is recurring, like circulating. Some numbers keep repeating. So this will be a fraction as well. Okay, this will be a fraction as well. But how I can convert that into a fraction? I'm not sure if you using. It's not going to be used in method, I think, but it's a good skill to know. It will be used in further. I think in further I saw questions similar to that. So put this into fraction form. So how do I put this into fraction form? Let's say the size of this number is x. Okay, x equals to that. So because it's 2 decimal repeating, okay, 212121 is 2 decimal repeating, I will enlarge that by 100 times. Well, if it's 3 number repeating, I will enlarge that by 3 times. So 100x equals to 21.212121 ... I will use equation 2 minus equation 1. What's left hand side equals to? Equation 2 minus equation 1. 99x. What's right hand side equals to? 21 only, because the decimal get cancelled. Just keep like circulating. So it's 21. So x is just 21 over 99. And x is 7 over 33. Done. That's in the fraction form. What is x? X is 0.212121. But 0.212121, x is also 7 over 33. If you put that into the calculator, you can see that's the same. Okay, if you put into the calculator, you can see that's the same. So all the circulating decimals can be done by this method. Okay, can be done by this method. It just depends on how many decimals is recurring. So if it's 3 decimals, you enlarge that by 1,000 times. If it's 4 decimal recurring, you put that like 10,000 times. So it depends on how many decimal places is circulating. Just one way, like we're not going to spend a long time on this, but just show you why circulating decimals will become rational numbers. And then rational numbers will use Q to represent that. Capital Q to represent that. Irrational numbers is like Q dash is the complementary set, like not Q. Okay, Q dash, not Q. So, well, what's the definition for Q dash? Something cannot be put into the fraction form. We use Q dash to represent. So what can't be put into the fraction form? It will be infinite recurring decimal numbers. So something just infinite many decimals, but like it's not a regular number, it's not circulating. So there's no patterns for the number. That is, for example, all these thirds, okay, all these thirds will be irrational numbers. Another two will be pi, will be irrational numbers. Okay, those ones are the special ones. You can directly see it. All these thirds cannot be simplified. Well, if you say square root 4, that's rational because there's a 2. But if it's like you can't get rid of the square root, that will be irrational numbers. And pi, if you learn later, there will be another number called e, natural numbers. Like that will be the same as pi. Pi is 3.1415 something, and e will be 2.71288. I can't remember the rest, so it will be 2.71 something. We'll learn that in chapter 13. Okay, we'll learn that in chapter 13, but it will be exactly the same as pi. It's a letter to represent a number. We have a button on the calculator like that. Okay, so that's rational and irrational. The last one we use is R. Okay, real numbers. Basically, everything in methods you learn is real numbers. Okay, everything you learn in methods, they are real numbers. All the numbers are real numbers. Well, there will be imaginary numbers or complex numbers in Spec, but if you're not learning Spec yet, everything you know so far is real numbers. So real numbers are, positive real number is R plus, like all the positive ones, you know, like not including 0. All the negative real numbers will be R minus, like not including 0 either. So the statement is not correct. So it will be R plus union, let's say R minus union 0 union R plus. That will give you the set R. Okay, so still we're missing the 0. Still we're missing the 0. We can see this Venn diagram, like N belongs to Z, Z belongs to Q, Q belongs to R. So I would say we have real numbers. It will be separated into rational numbers and irrational numbers. Well, there can be, number can be put in fraction, number cannot be put in fraction. There are only real, right, rational and irrational. And then in the rational numbers, we have Z plus 0 and Z minus, and Z plus are the same as natural number N. That's the relationship. Okay, that's the relationship. Like Z is a rational number. A rational number belongs to R as well. So that's how we talk about the number set. Okay, so the number set, we have R, N, Z, and Q to represent special things. Okay, so do not use those letters like randomly. So you can use A and B, C, A, D to give like name to other like set, but those letters are just used for talking about the number set. Okay, a large like R and N, they are natural numbers. So if we think about the notation, we use curly bracket. Do you remember when we talk about the set, like a curly bracket, a collection of X such that X is an element of A and X also an element of B. Like we use, that's called the set notation. But if we use that way, it's very complex and it's really long to write. Okay, when you talk about some numbers, you don't want to use like this long notation to talk about it. So we want to introduce a shorter notation to make your life easier to talk about the set. So there's another way to talk about set. When we don't have the curly bracket, how we can talk about the set. So if you can think about the set notation here, for example, this one is talk about a collection of X such that my X will be the number in between 0 to 1. if I can represent that on the set of x, that is a number line like this, like from 0 to 1. A little bit enclose that. So here, for the next one, we are talking about a collection of x such that x is greater than 0 and x is also rational numbers. Okay, x, like all say x belongs to Q. Rational numbers. X greater than 0 is a collection of x such that x is greater than 0, also x belongs to Q. Well, I can't really show that on number line. They are like dropped points, like different, like there are even many points, but like they are not, you can't list them out, you can't draw them. And for the last one, this is talk about 2n such that it's a collection of 2n such that what is n? N is 0, 1, 2, 3, 4. Well, I can write it in another way. So it's a collection of 2n which n belongs to n union 0. Okay, it's a collection of, well, what's n union 0? N union 0 is 0, 1, 2, 3, 4. Okay, 0, 1, 2, 3, 4. So also I can write in another way. It will be, you sub the value in, that will be a collection of 0, 2, 4, well, 6, dot, dot, dot. And I can say it's a collection of even numbers. It's a collection of even numbers. They're all equivalent. Okay, they're all equivalent. I can write them all in the same way. Because n is what? N is 0, 1, 2, 3, 4, 5. So we put n at 0, 1, 2, 3, 4, 5. The number you have is 0, 2, 4, 6, 8, dot, dot, dot. And you can see that's an even number set. Okay, it's an even number set. 0 is an even number. So it's an even number set. But just as I said, it's a very complex and long notation. We want to avoid that. For example, the first one, 0 to 1. It's very easy, just say from 0 until 1, right? Not including 0, not including 1. All the numbers in between that. So we introduce something called the interval notation instead of the set notation. Okay, so we have a start point and we comma end point. So that's how we do it. We want to get rid of the set notation. We replace it by the interval notation. Okay. Where do I start and where do I finish? Okay, that's how we write it. Where do I start? Where do I finish? Also, we have two types of bracket to use to can do it. So we have round bracket and we have a square bracket, or we can combine between the bracket. Okay, so round bracket means not include endpoint. Square bracket means include endpoint. Well, you can include the left, not include the right. Or you can include the right, not include the left. Okay, so that's how we do that. So give your example. Negative 2 to 3. Look at the first one. Its start point is negative 2. Finish point is 3. But round bracket, which means not including that. Okay, not including that. So I will draw negative 2 to 3, not including both ends, and then a line on the number line. So any number in between negative 2 to 3. If I can write a interval curly bracket notation, the set notation is a collection of x such that x is in between 2 and 3. Okay, such that x is in between 2 and 3. And then if I can draw that here. Okay, negative 2 to 3. Well, the next one will be 2 to 5, but include 2 and include 5. Start point is 2. Well, always start from a smaller number and finish with a larger number. So 2 to 5. So it's a set notation we want in between 2 to 5. Alright, so the other two will be very similar. Start from -3 but finish at 4, but not including -3 but include 4. Okay, you can do the next two by yourself. But the one I want to emphasize is the third one, like 1 to infinity. Okay, what's infinity means? Like 8, like in the horizontal way, not vertical way, so in the horizontal way, like 8. It's called infinity. Infinity means infinite large. Okay, so all the way to the right. So it's 1 and all the way to the right. This thing must be always on the right hand side. So you can't go infinity to some number. So infinity is already the most largest number you can have. So it must be on the right hand side. So smaller to larger. So that's a larger number. Infinity is a larger. Must be on right hand side. And this one must be bound with round bracket. You can never use curly bracket to put on the right hand side of that. So if you can see 1 to infinity, that means start from 1 all the way to the right. You can put the arrow there. And the way you can write it is x go for x greater than 1 or 1 less than x. X is greater than 1. The requirement is only bigger than 1. Anything will be fine. And if you can jump to the next one, there's a negative sign in front of the infinity. That's called the negative infinity. That must be on the left hand side. It must be on the left hand side. It can't be on the right hand side. So if it's on the left hand side and also needs to be bound with the round bracket. Okay, on the left bound with the round bracket. Well, I don't care what's on the right hand side. It can be any number. It can be bound with any bracket. But it must be a round bracket to give the negative infinity. So it's -1 to the left. So x less than -1. That's in the set notation, and then on the number line what that means. So there are 4 more questions. Give your 3 minutes to complete the other 4 we haven't done, which they are really easy. Okay, there's a -3 to 4, -2 to 0, and there's a 2 to infinity and -infinity to 0. So 4 more. Let's have a look together. -3 to 4. We start from -3, but it's not including -3. Until 4, include 4. So open circle to close circle and then connect them. So in the bracket, it says it should be a collection of x such that is including, not including -3, but including 4. So x is in between -3 to 4. Next one is -2 to 0, but not including 0. So it's a short one here. It's a collection of x such that -2 smaller equals to x and smaller than 0. The next one, 2 to infinity, inclusive 2. I want 2 and all the way to the right. So it's a collection of x such that x is greater or equals to 2. Last one we have will be start from 0, included 0, but all the way to the left is x less than or equals to 0. That's all for exercise